Welcome to my screencast. My name is Kelly Bragg, and for my presentation, I covered technical metadata for digital still images. This screencast will cover two topics. First of all, how NISO Z39.87 fits in with OAIS, and secondly, I'll be using Adobe Lightroom to examine different image files to get examples of what automatically created metadata looks like. Quite a few digital repositories presented in class discussed Oyster. That's the open access digital object resource known as the Open Archive Information System. And METS, which is the Metadata Encoding and Transmission Standard, was also discussed during class. Now, one of the articles I read for learning more about the NISO described it as being the innermost of three nested Russian dolls, in that one is located within another's framework. And this diagram shows that pretty well. The OAIS is the model specifying responsibilities and data flow surrounding a digital archive. METS provides the data structure for exchanging, displaying, and archiving objects. And then we get down to the NISO, and you can see that that takes the image, the digital object, and gives all the parameters necessary for future retrieval and storage of the object. So we use NISO, but how are the fields populated? I visited Xerox and found a document describing how they use these things called sockets in their content intake manager to read the metadata structures. If we go to the top of the page, we can see all the kinds of files that the multiple document channels read. So the content intake manager can do anything from fax servers to JPEGs. And then if we look down here at this diagram, we see that the content parsers go in through the sockets. The sockets decide how the information should be shared and managed, including metadata, and then it's sent to the repository. I really like this diagram for how well it sums up what the actual software is doing with those files. So let's take a trip over to Lightroom. And as you know from class, the NISO Z39.87 requires special software to read. I mean, that thing is better cloaked than a Klingon warship. So, to approximate what the metadata capture might look like using one of the software products that would be sent to the Cultural Heritage Center, I took three items. This first one is just a scanned JPEG from a really cheapo HP printer. And over here in metadata, it's just the default metadata. We can see that it has the file name, the folder it's stored in, and the dimension. If we do EXIF and IPTC, we see that the file size and the file type have been added. If we go to pictures from a digital camera, we can see that this one's filled up quite a bit more. We can see the make and model of the camera, the serial number of the camera, who took the picture, the ISO speed rating, the metering mode, the exposure and the dimensions. I mean, it has everything. If we go up to default, the screen changes a little bit, but we still have the dimensions, the exposure, and the capture time. If we go to one of the pictures I took from my droid, and I really like the histogram up here. Anyway, if we go to one of the pictures I took with my droid, we can see that the metadata is indeed different. The focal length is different. The exposure and dimensions are different. The flash also did not fire. We see that it's a Motorola droid. And we see the file information. If we go and compare that to the EXIF and IPTC from the Canon picture, we see even though it's a Droid X, it's not a Canon, it still has quite a bit of metadata embedded in the image file. So no, this isn't the really cool NISO Z39.87 that we'd see, but it gives a good rendition of what that might feel like if we're altering the data. You can see that we can alter the metadata just like we could for a NISO Z39.87 record. So I think this gives us kind of a layman's viewpoint of what that might look like. So thank you.